We're back. Oh, come on. Just a minute. Oh, come on. It's slow now. I'm still on my phone. Okay. Now it's working. Did we get the Wi-Fi? No. I still don't know if the Wi-Fi still works. No, we could check with the tablet. So according to the tablet, the Wi-Fi is working. Nope. It's just connected. Not working yet. At least the stream is going on, right? I'll continue with the studies. Grr. Assignment number 2. How does electric charge in an isolated system behave? If I remember last time I read this, what is the underlying principle? Does this principle apply consistently in system of all sizes? I don't remember. An isolated system, the total electric charge is conserved. How does the electric? Okay, it's conserved. That's the answer. Conserved. This means the net charge, the algebraic sum of all positive and negative charges, remains constant over time. Okay. How does the electric charge in an isolated system behave? What is the underlying principle? Does this principle apply consistently in system of all sizes? Underlying principle, the principle is law of conservation of charge. Charge cannot be destroyed or created. It can only be transferred from one object to another. Applicability. Yes, this principle is fundamental law of physics and applies consistently to systems of all sizes and from subatomic particles to the entire universe. What are the similarities and differences between Coulomb and gravitational forces? What can you say about their magnitude? Which forces dominate at large scale structure and which at atomic scale? Celestial bodies. Yes, this principle is fundamental law of physics and applies consistently to systems of all sizes, but system of all sizes from subatomic particles to the entire universe. Entire universe. What are the similarities and differences between Coulomb and gravitational forces? What can you say about their magnitude? Which forces dominate at large scale structure and at which at atomic scale? How does the electric charge in an isolated system behave? What is the underlying principle? The electric charge inside an isolated system would be conserved because it's an isolated system and it does not have any connection with outer world or other system. What is the underlying principle? It's the law of conservation of charge. Does this principle consistently apply consistently in system of all sizes? Yes, this apply consistently to systems of all sizes. What are the similarities and differences between Coulomb and gravitational forces? What can you say about their magnitude? Which forces dominate at large scale structures and which at atomic scale? Starting up. Law of conservation of charge. It's too bright outside. So it applies to all substances, structures of all sizes. What can you say about their magnitude? What are the similarities and differences between Coulomb and gravitational force? Inverse law. Okay, I don't know that. Inverse square law. Both are central forces acting along the line joining two centers of the objects. Both are conservative forces. Mhm. Gravitational force acts between two masses. Coulomb force acts between two charges. Strength: the Coulomb force is vastly stronger than gravitational force for fundamental particles. The constant is much larger than gravitational constant. Direction: gravity is always attractive. Coulomb force can be attractive or repulsive. Depends. Magnitude and dominance. For individual particles like protons and electrons, Coulomb force is about 10 raised to 39 times stronger than gravity, therefore it dominates at atomic molecular scale. However, large celestial bodies like planets, stars, overall electrically neutral, they have equal number of protons and electrons. The gravitational force, which is always attractive and cumulative with mass, is dominant force at this scale and governs the large scale structure of the universe. Equilibrium of a proton. Q1 equals plus 8Q at x 0 Q. Oh, that's a question, right? Mm, so Coulomb can be attractive or repulsive. Uh, the constant for Coulomb force is higher compared to gravity. The constant is much larger compared to gravitational constant, and Coulomb force Coulomb acts between two charges, while gravity acts between two masses. Gravity is always attractive force. Coulomb can be attractive or repulsive. Okay. Figure 1 shows how two particles fixed in a place, a particle of charge q1 and at the origin, and a particle of charge q2 at x equals L. At what point other than infinitely far away can a proton be placed so it's in equilibrium? I know this question, but let me. So you use the Coulomb's law, K multiplied by product of charges by R square. R, what is R? The proton must be placed along the line connecting the two charges. The force is region 1, x less than 0. The proton is repelled by q1. These forces, q1 is positive, q2 is negative. No way, fuck. The Wi-Fi is still not working. Yeah, this is no, there's no such point. The proton cannot be placed in equilibrium. What? What the? There is one point. I do remember this. Dude, this is not right. I gotta send the email. Tough. Okay. Okay, I do have some big problems coming up. Okay, I gotta rewrite some of the protocols. Mhm. Section 2. 3, 5. Yep. 1, 2, 3, 5. Mhm. Okay, let's first complete this physics assignment, then I gotta start with the protocols. The Wi-Fi is still fucked up. What? Dude, what's wrong with the Wi-Fi? Mm-hmm. Using Coulomb's law, 1 by 4 pi epsilon 0, the x component of the net field of e x minus L the whole square. What is x? The proton E is placed somewhere on the x-axis with x from the origin. Okay. Substituting Q1, Q2, and 1 and 2 into 3. X equals 2L. The proton experiences no force when it's placed in a position 2L from the origin. That is equilibrium. So Q2 is minus, so it's gonna attract the proton. Clone open commander, we back. Yes, we are back indeed. And I do have a lot of shit to do. I just realized my lab protocols had some issues, so I have to do those. And my Wi-Fi is not working. It's not a good day. It's not a good start. Is Twitch working? Cause I don't know how Twitch is handling this low data speed. Yep, it's 1 minute. Yep, Twitch keeping on cutting. 11 minutes, 10 minutes, 16 seconds, 21 seconds. Oh my god. Yep. Twitch is having a hard time. What can I say? That's also cut. Clone open commander, can you hear me? Proton is x minus L. If x minus L is a negative positive, it doesn't matter because it's squared. Okay. K0. Useful constants epsilon 0. There's no equal to. Newton per meter squared. Newton per meter coulomb? Okay, that's the first question. Now, the charges Q1, Q2 are located in the corners of the square with side length L equals 4 centimeters. The charge Q1 equals 1 coulomb. The charge Q3 equals minus 2 coulomb. What sign must the charge Q2 have so that no total force acts on the charge Q1? What signs must charge Q2 have? Ooh, charges Q2 are located in the corners of a square with side of length. The charge Q1 is 1 coulomb. Q2, the charge Q3 is minus 2 coulomb. What sign must the charge Q2 have so that no total force acts on the charge Q1? Okay, now we got Q2 in the opposite directions. How must the charge Q2 be chosen so that the total force on Q1 disappears? It should be these two attract, so and Q3 has more value than Q1, so Q3 is gonna pull Q1. So we need is a positive charge at Q2. Sketch the forces acting on the charge Q2 and Q3. Do the total force acting on Q and Q3 also disappear? Do the total force acting on Q1, I believe they disappear. They could disappear. So net force at Q1 is 0. Okay, Q2 equals positive. Yeah. F of 1, 2 equals L square. F reactant of xy equals F of 1, 2. Mm-hmm. F of 1, 2. Okay, this is the x. This acts accordingly on the x-axis. Y-axis, the reactant is F resultant equals minus of F3. The four. Okay, now F3 is Q1 Q2 by R2 R13 is root. Okay, we get Q2 0.707 coulomb. Okay, that's Q2. I'll try that. F resultant. I did not know this formula. Okay, that's the diagram, or it's a bit. Two identical spheres carry an equal amount of electric charge Q plus 1 coulomb. What mass is required for the spheres in order to compensate the repulsive coulomb force by attractive force of gravitation? Two identical spheres with mass m equals 1 kilogram carrying an equal amount of electric charge. What charge Q is required for the spheres in order to compensate the attractive force of gravitation? Identical spheres carry an equal amount of charge 1 coulomb. What mass m is required for the spheres in order to compensate the repulsive coulomb force by attractive force of gravitation? Two identical spheres with mass m equals 1 kilogram. Two identical spheres carry an equal amount of electric charge. Watch mass compensate the repulsive. Oh, repulsive coulomb force by the attraction of gravity. The two identical spheres with mass m of 1 kilogram carry an equal amount of electrical charge. What charge Q is required for the spheres to compensate the attractive force of gravitation? Uh-huh. So first we start with 1 coulomb. Repulsive coulomb force equals attractive. Repulsive coulomb force should be equal to the attraction by gravitation. So the force produced between the two charges Q1 Q2 equals the gravitational force between attraction between these two charges, and m1 equals m2, q1 equals q2, right? Q1 identical spheres. Yep. So m squared is equal to k by q1 q2. K is now 8.910 raised to 9. This is a significant mass for a sphere of charge 1 coulomb. Yep, that's a big boy. Now for the next question, the same equation, but we're gonna, well, the mass is constant, the charge is not constant. Significantly low charge for a mass of 1 kilogram. Voltmeter per AS. What's AS? Ampere second. What? What? Yep, so I do remember how to solve these questions. Now it's time to solve. Solve on my own without any sort of comprehension questions. How does an electric charge in an isolated system behave? What is the underlying principle? Does this principle apply consistently in system of all sizes? So, electric charge in an isolated system would be conserved. What is the underlying principle? It follows the law of conservation of charge. Does this principle, yes, this principle apply consistently all sizes? Both follow f inversely proportional to 1 by r square. What are the other similarities? These forces exist over a long time. I don't know. Let me see the similarities. I actually forgot. Not these, bro. Get the hell out of here, bro. I just need to see the similarities. Stronger similarities. Inverse square law. The strength decreases with square of the distance. Okay. Central forces. Okay, though. Yeah, I do remember. Yow. Clone Open Commander, I am really sorry for the inconvenience. My Wi-Fi is not working. I had to use my mobile hotspot. That's why Twitch is tweaking. Oh no, I'm sorry, Twitch. Twitch is... Oh, I'm so hungry, bro. For fuck's sake. Yeah, I see that you're cutting in and out. Darn it. Gosh darn it. Yeah, at least let me write the... So similarities both follow the inverse square law, and both are central forces acting. Now the similarities: gravitational force is fundamentally an attractive force gravitational force is fundamentally an attractive force. What else? Electrostatic force can be attractive slash repulsive. The Coulomb force constant is much higher compared to gravitational. What else? Next question. Yeah. What can you say about the magnitudes? I think that's what I said, right? Magnitude. Stronger, weaker, acts between charges, acts between masses. Yeah. What was the part with the magnitude? Plays a huge role in atomic scale, celestial scale, can be both, always attractive. Okay, I mean, nah, this is not what I wanted. So I already wrote the stuff I need to, okay. And gravity is stronger on celestial level, celestial scale. while Coulomb is stronger in atomic scale. No, it's not good to meal snail. First question. Figure shows two particles fixed in a place, a particle of charge Q1, Q1, and Q2. The distance between them is L. Q1 is plus 8 Coulomb. Okay, Q2 is minus 2 Coulomb. Now, placing a proton on the x-axis at a distance of x from origin, in which it will be in equilibrium. F net equals FQ1 plus FQ2 equals 0. FQ1 equals minus of FQ2 experienced by the proton. FQ1 equals K0 Q1 E by F equals K0 Q1 Q2 by R squared. FQ2 K0 Q2 E by X minus L the whole square. Oh shit. Oh shit! So K0 times Q1 is 8 Coulomb. 8Q times E by X squared equals K0 minus 2 minus times e by x minus l the whole square, k0 k0 e 8q equals 2q by x square by x square minus 2xl plus l square. Sixteen xl plus 8l square equals 2x square. What? Just a minute. I don't remember them saying anything about the internet. Hello, let me tell you how to be a zero. No, I missed something. X minus L by X the whole square equals 2 by 8. This is a 1 by 4. X minus L equals 1. X equals 2. No, that's just wrong. X equals 2x minus 2L. X equals 2L. Yep, got him. Got him. Okay, that's done. What do we do? So the proton should be placed Q2, Q3. 1 unit. Let me pull this out.
Okay, now it's out. Let's pull shit in.
Mission solved. $82 kbps. 34. Are you working? I also landed on some big trouble. Trouble. F of q2x equals k0 q1 q2 by 1 square. Q, how much is q2? Oh, we have to find q2. Q2 equals q1 equals 1 coulomb. F of q2 y equals the same k0 q1 q2 by f resultant q2 equals root of fq1 x the whole square plus fq2 q1 q2 q2 y the whole square. Square q1 q2 square so that's root 2. Root 2 times k0 q1 q2 by 1 square. Now f resultant equals to f q3 k0 I believe the Pythagoras theorem 2 whole square, yeah. So that is q1 q3 by the distance, that's L root 2 or 1 root 2 or root 2 k0 q1 q2 by 1 square. Q1 k0 is cancelled, 1 squared doesn't matter, q3 is 3. No, minus 2. So minus 2 by 2 minus 1. That's just wrong. Q1 is 1. Yep. Root 2 times, okay, k0 q1 q2, we got a root 2. I forgot about the root 2. So minus 1 by root 2. What the fuck is wrong with the root 2? I don't know if root 2 makes sense. How much is 1 divided by root 2? 0.7. Okay, but I got minus. That's negative. Attract. It's already attracting, so. Oh, if resultant is minus a fifth root. Okay. That's what I should be looking at. Okay, now it makes sense. So Q2 equals 1 by root 2, which is 0.707 coulombs. Now, what's the next part? B. How must charge Q2 be chosen so that total force... What sign must... Okay, well, first question was what sign? Q2 must be positive. How must charge Q2 be chosen? The charge Q2 Q3 Q2 Q3 FQ12. Now for Q3 it's all negative. F no 3 2 F13. So Q3 is actually being pulled. Wi-Fi working, but these fuckers did not hear their shit. Nope, the Wi-Fi is still not working. Okay, what's the next question? Third question. Two identical spheres what mass m is required for the sphere in order to compensate the balance. So electrostatic repulsion equals gravitational attraction equilibrium. So electrostatic potential K0 Q1 Q2 by R square equals G0 M1 M2 by R square, I believe. So mass is equal m square equals K0 by G0 Q1 Q2 equals 1 times 1 equals 1. So K0 by G0 K0 equals 1 by 4 pi epsilon 0. Don't make me do this. Oh, 1 by 4 pi into 8.854 into 10 raised to 12. Four times pi into 8.5845. 111.261 divided by 0.08. Okay, so now we take 3 zeros. 8.98 into 10 raised to 9. 10 raised to 9 divided by 6.67 into 10 raised to minus 11. We're going big numbers. One point three four. 1.34 into 10 raised to 20. That's right, yep. Charge, what charge is required for the sphere? Q2 by R square equals G0 M1 M2 by R square. R square cancel. Q1 Q equals G0 by K0 equals shit. G0 is 6.674 into 10 raised to minus 11. K0 is 8.98 into 10 raised to 9. Zero point 0.743 into 10 raised to minus 20. 8.62 into 10 raised to minus 11 coulomb. That's what I think is C. Okay, let's see if the answers are correct. 8.62. Oh, 8.59 into 8.62. Yeah, almost. 1.16 into 10 raised to 1.157. Yeah, 1.16. 707. Yeah. 12. Yeah, that was correct. Now it's assignment number 3. But before that, I gotta go cook. I'll cook real fast. Because I gotta eat. Gotta eat and continue.